People that have a chance of getting to the top 100 leaderboard globally, they solve the problems super fast, like 15 seconds.
Welcome to Nerd Out at Spotify, where we bring you behind the curtain of the world's most popular audio streaming subscription service. Machine learning, open source, clouds, tabs versus spaces. We'll talk to Spotify engineers about interesting tech issues, big and small. Hello, I'm Dave Zolotusky, principal engineer at Spotify. The days may be getting longer and warmer, but today we're taking you back to that special time of year when Sweden is cold and snowy, the air is filled with holiday cheer, and our engineers become completely obsessed with solving coding puzzles. That's because every December at Spotify, our engineers compete against each other and themselves, trying to solve the coding puzzles on adventofcode.com. The website was made for fun by a programmer named Eric Wastel. He launched it back in 2015 on December 1st, expecting a maximum of 70 participants. A couple of days later, over 15,000 people were on the site trying to solve his puzzles. Last December, there were over 220,000. And judging by the activity in our Advent of Code Slack channel, that includes a healthy number of Spotifyers. The site works like a regular Advent calendar, except instead of revealing a chocolate treat or toy surprise every morning, you get a coding puzzle to solve. A new puzzle is revealed each day at midnight Eastern Time in the US, which is 6 o'clock in the morning here in Stockholm. If you spend all day coding for a living, why would you also get up early to code for fun? Well, this episode we'll talk to a few Spotifyers to find out why software engineers can't resist a good programming problem. And
we'll talk to the unbeatable Jimmy. But first,
we're starting with our chief architect and VP of engineering, Niklas Gustavsson, or as we usually refer to him, both online and in real life, his three-letter handle, NGN. So I want to start by just having you tell us a little bit about your role at Spotify. What does a chief architect do, and what has your career been at Spotify to get you to this role?
I started at Spotify 10 years ago as a backend engineer, and obviously, we were a much smaller company at the time, and as an engineer, you tended to work on a broader set of systems. So when I started, I worked on what was some of our core systems at the time. Then I sort of narrowed in on the playback stack. So essentially the stack where we distribute content to our clients and then play that audio. And might seem like a very trivial problem, but turns out to be quite challenging to do well and to do at scale. And then for the last few years, I've been focusing on my current role, and that's really to look after our overall architecture and tech stack and engineering practices at Spotify. I run a group called the Technical Architecture Group, which is really a bunch of representatives from the various parts of the company, and we try to sort of align on where are we going, what technologies do we want to use. We have a tech radar to communicate that and provide guidance and really be opinionated about what our architecture looks like. Secondly, I tend to identify and initiate, and in some case drive, more strategic initiatives. I think most of the actual architecture that we end up with is very emergent. Like, it doesn't come out of my head or out of Tag's work. It comes out of the thousands and thousands of small decisions that every engineer helps take every day. And my work is more to sort of help steer that in the right direction.
Can you explain what Advent of Code is and tell us a little bit about how you discovered it?
So Advent of Code is this amazingly fun thing that happens in December every year. There's a guy called Eric Wastel who comes up with a set of programming challenges that you get to solve. And there's one challenge released every day, the first 25 days of December. What actually happens is that every day there are two-step problems. Like you get the first problem, you solve that, you get your answer in, and once you have the correct answer, you open up a second sort of phase of that problem. And that typically has some sort of change that will more or less invalidate your first part of the solution. Like, you'll have to rework that because it doesn't scale, or the sort of fundamentals of the problem was changed some way. And then in addition to that, there's sort of sprung up this community within Spotify around Advent of Code. So there's a very active Slack channel during December where people are hanging out and discussing these challenges and whatnot.
Can you kind of walk me through a typical Advent of Code morning for you?
So I typically have my clock set for 5:45, I think. I go up, I make a cup of tea, I try to get my eyes into working order, and I sit down with my computer. I have this script to sort of set up all the things that I need for each day. And I tend to run that in the morning to get a little bit sort of warmed up, and then counter on the Advent of Code site, you sort of sit and watch as it ticks down towards opening up the problem. Once the problem actually opens up, it depends a lot on the problem itself and my sort of understanding of it. So typically you read through this set of pros, always with some Christmas story, and you try to figure out what's actually the problem that you're supposed to solve. And for some of those, you might have a reasonable idea what the solution might be. And in some cases, I have no idea. And those mornings looks very different. Sometimes it's very quick. You finish it up, you get the answers in, or it takes hours and hours and hours. And I get more and more frustrated and I have to take breaks and eat breakfast or get the kids to school or whatnot. And then once you have solved the problem, what I do is always to go into that Slack channel, because I actually find that to be maybe the most fun part of Advent of Code, is to sort of hang out and discuss and compare and contrast solutions afterwards. And there's some people at Spotify that are extremely clever, so I tend to learn quite a bit from just seeing how they solve the problems. And it always makes me feel incredibly stupid, because I always ended up solving the problem in a very brute forcey way compared to someone that actually might know what the right algorithm would be to use.
So I feel like for all of us, we have one problem every December that we solved the right way. And then for the other 24-ish, we learn from the people in the Slack channel.
Yeah, I think that's very true.
Tell me a little bit more about that then. What does this community look like, and what are the interactions on the Slack channel like?
We have a leaderboard, which is something that is available on the Advent of Code site, where you can have these like private leaderboards. And then there's the Slack channel with, I guess, more than 100 people at least hanging out and discussing. And there's also, of course, some fun going on. Every now and then we'll come up with some additional challenges. Typically when Advent of Code ends, there's always someone who's eager to continue. And then I would say some amount of sort of friendly competition around the leaderboard. If you're the first one on that leaderboard to solve the first part of the problem, you get some number of points. If you're the first one to solve the second part, you get some number of points. And these points then add up during the month. So you have this like stack ranked list based on how fast people have solved the problem compared to everyone else on the leaderboard. Then there's also a global leaderboard, which is the fastest 100 solvers every day. For me, that's part of my stretch goal for every year, is to get on the global leaderboard one time per year. And I typically do not make that goal. I did not make it last year. But we have Jimmy, who I think is also being part of this podcast, right? And he's amazingly fast and is typically on that global leaderboard.
Jimmy?
You heard right. He's talking about Jimmy.
Do you have specific problems that you kind of remember particularly, either fondly or whatever the opposite of that is, or that you hate to this day with a passion?
I tend to remember the problems that I struggle with. By far the worst one that I had, I think it was from 2018. It's called Reservoir Research, and it's about how this like water flows through these reservoirs. And I don't know how many hours I spent on that, but a crazy amount during that day. I couldn't wrap my head around the problem, and my solution ended up being very messy and thus even harder to work with and figure out. So that, I think, is my number one problem that I still remember. I think from this year was the snailfish number thingy that I struggled with as well. And I did sort of similar, like I did this like very messy binary tree type of thing that I could never really figure out how to work with, and then ended up just removing it and doing some very ugly string parsing that took me like 15 minutes to solve the problem. So out of the 25 problems in a month, I probably enjoy like 20 plus of them greatly, but I never remember those problems.
That's funny because that sounds fairly similar to me, and I remember both of those problems vividly, but for slightly different reasons. The reservoir one I remember because I was used to getting up in the morning with you guys and like seeing how quickly people answer things. And I remember I didn't get it in time before I take my kids to school and get them breakfast. And I looked and you didn't either. And then I got to work after this hour of walking the kids to school and all of that. And you guys still hadn't gotten it. So of course I was like, well, now I have to keep trying. And that was a day when I don't know if I should be recording this on a podcast, but I spent like a good chunk of my work morning hiding in a room on the side, just like trying to get it, and eventually got it done, and then went and actually did my job. And for the math one, I did the opposite of what you did. I tried to do some crazy string parsing stuff and couldn't get it at all. And then I somehow in the middle of all of that, in my head, figured out a way to do it with the tree very quickly, and then kept not coding that because I was like, but I'm so far along this string one.
Yes.
And then finally threw it out, and it took me like 10 minutes and I was done when I just rebuilt it the other way.
Yeah, so that was exactly what I was doing with, again, opposite solutions. But yeah, I was so into that binary tree thingy that I just felt like, I know I've invested like 2 hours or whatever into this piece of garbage that I have. So now I really want to figure it out. Couldn't figure that one out either. And then basically regressed down to string parsing, which was an ugly way to solve that problem, but worked out. So this is also part of the challenge with the two-part aspect of the problems, is that I often get into a mode of thinking if I do too stupid of a solution on part one, that's going to bite me on part two. And that's very often not the case. So like it's often I find that I can rework even a hacky solution into solving part two.
Yeah, I think for those of us that have done enough of these problems, you end up trying too hard to make your part one solution work for part two without knowing what part two is going to be.
Exactly.
And like 99% of the time you're wrong. So like one problem every fourth year, you will have done the right thing in part one, but for the other 3.5 years, it's a complete waste of your time on part one.
Yep, that's exactly the case. I need to learn not to try to predict what he's done with the problems, because he tends to come up with quite clever changes to the part two.
I want to go back to the place where you talked about there being a bunch of kind of difficult problems and stuff you learned from Advent of Code. I'm curious if there are things that you've learned from doing it that you really remember, or that you're kind of really grateful for knowing that you wouldn't have run into otherwise.
I don't have a computer science background, so for me, I don't have the sort of theoretical background when it comes to algorithms and data structures. But generally speaking, I like just to get to every now and then code these types of algorithms that you might have read about or you might have used 10 years ago, but now I get to use them. And it's a good way to sort of exercise that. And I solve most or almost all of the problems in Python, and I do a decent amount of Python programming at work as well. And at least for me, I've found that it's improved the way I write Python, the way I think about solving problems in Python, in terms of like the typical graph search algorithms or working with binary trees, as we talked about before. Like those are pretty rare in my day-to-day job. So I really enjoy getting to exercise that and relearn or learn those things. Now I've actually built up a sort of util library that I use now for Advent of Code. And if I go back in there, I now have implementations of A* and these types of algorithms that I've sort of built up through these problems. And even though I might not be able to use them directly as a library, because the problems tend to require some customization, like I have a starting point, and that I think has been extremely both fun and learning opportunity to build up that library and improve it year over year, and like figuring out new algorithms to add to that library.
I would say the same thing for me, except instead of having this sort of library, I tend to just dig back through my old code, trying to remember where something similar is, and then copy and pasting it again. And what you do sounds much smarter.
I didn't mention this before when you asked about the typical morning, but I think most people do this. But once you've solved the second part, what I at least do is that I go back and sort of clean up my code. What that typically entails is removing lots and lots of those asserts and like print statements and whatnot that I have mixed into the code just to figure out bugs or whatnot. And then maybe rename some variables to not be like X and Y and Y, I and J, as everything is called when you solve it first. So that's also part of the routine, I think, to have something that I can go back and read and understand myself.
I'm the same, though. I've made a rule for myself that the only thing I do is remove print statements. And otherwise, I submit the code as is, effectively to show, like, this is the thing that I did in that amount of time. And I will not, like, lie to myself and pretend that it was cleaner and the variables were named better or whatever.
All right. Well, I lie heavily to myself because I definitely do more cleanup than that.
You mentioned earlier that with these problems, sometimes you have no idea. And I'm curious what you do in that case.
I tend to use a few different approaches, I think. One is starting to scribble on a piece of paper. And it's mostly, I think, me getting my head around the problem and like being able to break the problem down into small chunks that I can start to take on. So that's a typical one. And then I might be able to get into taking on some part of it. And that, I think, sort of brings me into the second alternative, which is what I think I most often do. And that's just try to solve this smallest part of it that I can figure out and then just incrementally take it from there. And there was one this year with the beacons. I think it took me like 3 hours to solve, but I always were able to move forward in small increments. And then, of course, like then you talk to others who have solved this and they came up with this like one magic matrix multiplication or whatnot to solve the problem. And I have like 200 lines of messy code, but it's at least like I've been able to make that progress. Those types of problems tend to feel fun. And then there's the third class where I have no idea. And I typically just stare at the screen for like 2 hours and then start randomly Googling for things that I might come up with on the problem. The one that I can think about, I don't actually remember what the problem was about, but the solution was to use the Chinese reminder theorem, which, again, not having a CS background or math background, I have no idea about. But I was able to, like, by 100 different Google searches, find some clue on that and then read up on that algorithm and like, yeah, this is exactly what I'm looking for, and then was able to code that up and get it in to solve the problem. But those problems, they tend to be like rare when I get that stuck, but they take me a long time and I don't find them to be particularly fun. They're just frustrating.
I remember both problems that you're referring to. I can't remember when we used the Chinese remainder, but I remember very similarly just like giving up and digging around and eventually tripping over it somehow. And I'll say I do have a formal CS degree, so maybe I'm an embarrassment to people with formal CS degrees, but I run into all the same problems that you do.
I mean, it's part of the struggle, right? And I think it's part of learning and figuring out these things. I remember there was something around like you have these dependencies and you have to sort of resolve this tree of things and then figure out the fastest way to, it was mixing some chemicals or something. I don't remember if it was a few years ago. And I remember like struggling for a long time with that problem. And then once I solved it and got into that Slack channel, someone had just mentioned like, yeah, this was obviously a topology search and just had whacked out that algorithm and solved it in minutes. And if I would only have known even to look for that, of course, it would have been much faster, but I don't. So I'll have to do it the harder way.
Yeah, no, I feel like there's always that. And to your point about the leaderboard, every once in a while, there's somebody who's like midway down it, and all of a sudden they're done in 2 minutes because they're the person that thought of it, and none of the people that are winning every day think of it. I think those days are really fun for their own reasons. Awesome. Well, thanks for joining us.
It was a good chat. Thank you.
There are a few hundred people in Spotify's Advent of Code Slack channel. It's most active in December while the competition is happening, but you'll find threads in there all year round. As you'll hear from our next guests, 3 of the engineers from that channel, just because the competition's over doesn't mean you've stopped thinking about the problems.
Hi everyone, I'm Sophy. I work as a backend engineer at Spotify, and I have been here for 1 year and 3 months now.
My name is Thomas. I'm at Spotify since October 19, so 2.5 years now. Mostly a backend developer, but now working with a lot of infrastructure tooling stuff.
So I'm Sandra. I'm a backend engineer here. Currently, I used to be a client developer before that. I've been in a lot of roles throughout the years. I've been here since 2010.
We have a pretty fun topic today. We want to talk about Advent of Code that I think all of you actively participate in and love. So first, I want to start just here a little bit in your own words. What is it?
For me, Advent of Code is a combination of competing against friends and strangers, learning a bunch of new stuff, and it's also a way to learn new things about programming in a constrained environment where you don't have to worry so much about who's going to read your code when you're done. I don't have a comp sci education. I'm a physicist by training, so I have learned a lot of computer science stuff from doing Advent of Code.
Yeah, I totally agree with Thomas. I also see it as a great way to learn new programming languages or even like programming paradigms. I think one thing good about Advent of Code is that compared to other coding competitions, it allows you to be creative. You can use like any languages. I've seen people using, for example, Excel sheets to solve the puzzles and other fun methods. It makes me feel clever, which I don't normally feel.
I love having these quick projects, but I rarely have any good ideas of what to do. And then every December, you get these like weird, fun puzzles to solve, and you just always have something to do. It's like a good idea bank of problems to approach.
So the next thing I want to talk a little bit about is what does a typical day for you participating in Advent of Code look like?
I basically changed around my entire day for this thing. So originally, the first time I did it was in 2019. I just figured like, yeah, I'll check it out. I'll do some of the problems. I won't get up early or anything to do it when they are released. That lasted about 4 days. And then I got up at 6 o'clock when the problems were released, which is like, that time doesn't exist for me otherwise. So whenever December comes around, I get up super early. I'm like ready with my computer, ready to go. It really changes my approach to the whole month. This whole thing of like getting how long you took on each problem allows you to compete against yourself a lot, which I really like see that I'm improving over time.
I think that's a very typical story where it lasts 3 or 4 days before you start getting up early and doing the problems. But I think it's really cool that you said that it's more about competing with yourself and seeing that you're getting better than that you're up because you know other people are and you want to beat them.
Yeah, I don't feel like I'm competing with other people. I mostly like doing it for my own sake.
I actually don't have the mental strength like Sandra to get up at 6 o'clock every morning. And I also found out I get stressed easily and I get distracted from work if I have unfinished problems. So last year what I did was I would start doing it after work and try to finish it before going to bed.
I like that. I think that eliminates a lot of the other people competitive aspects of it. And I know for all of us, we've had mornings where we show up at work and haven't solved it yet and then have questionable productivity throughout the day.
Yeah.
I'm a night owl, so I stay up late without noticing that it's late. My wife will start like preparing to go to bed, and then she comes out to me and says very pointedly, "Good night," and goes to bed. And if I haven't shut down my computer and started preparing for bed by then, I know that now I'm prioritizing wrong in my life. Preparations for Christmas, that's lower on my priority list than on my wife's, for example, because I also want to make sure that I have time for all the problems. And the closer we get to Christmas, the more time I need because the problems are harder. I actually had several days this last December where I brought my personal laptop to work and had it sitting on my desk so that if I was waiting for some compiling or a data job or something, I could write 4 characters on the code for Advent of Code and see if I could get one little tiny step closer to the solution and then go back to work. Part of the thrill about this is that you get very many opportunities along the way to feel like, yes, I'm almost there. I've almost solved it. Just a little bit more and I'll be done. And if you feel like that, it's just 5 minutes, 10 minutes more. And you feel like that for an hour and a half, that can easily just fly away.
I'm curious how often that really lasted for 4 characters while you waited for something versus like every time you shift over, it's half an hour and then you come back. And because I've definitely done that a few times. It's either I solve it or I'm at least doing 15 or 20 minutes before I get back to the work I was doing. What keeps pulling you back specifically to this? Like every December you do come back. Is there something that you can pinpoint that really gets you to get up at 6 o'clock in the morning?
For me, I think it's that it feels so doable in a sense. The problems, you can spend a few hours on them and you can solve them and you can kind of be done. If it were like a lot harder problems, I would probably bounce off them because I wouldn't want to spend that much time on them. It's more like a fun morning puzzle than a big commitment.
I don't want to underestimate the power of the community on me here, because obviously having been engaged with Advent of Code for a bunch of years now, it's more natural to do come back than to not. But there's also like, as soon as we enter even late October or at least early November, people will start posting like, oh, soon it's Advent of Code, and what language are you going to do this year? And do you have any nice library functions that you want to share that can help others? So when you see that excitement building up for it, that also helps getting excited about it and triggers the sort of want to come back.
For me, it's also a special household thing, because me and my boyfriend, we tend to have this little competition on AOC every year. So I can't lose. I have to participate too.
Who usually wins?
I don't, but he's usually using the easier language like Python. No offense to Python people.
Honestly, it does feel a bit like cheating, I have to say sometimes.
Yeah, I've done most of the problems in Python, and I fully agree. What do you do when you struggle? I know when you keep making progress and you're getting closer and closer to the answer, it makes sense to just shift back, do a few more minutes here and there. But what do you do when you really start to struggle, when you really don't know what the next thing to do is?
It really depends on the problem. If I understand that, okay, so this is a math problem, I need to figure out the correct theorem to use here, then I would go to Wikipedia on some related topic and hope I stumble upon the correct theorem or something. For me, the fun is actually trying to solve it by myself. So I basically bang my head against the wall until I figure something out.
I agree with Sandra. I've also seen people posting in our Advent of Code channel. So they tend to ask, can you give us a hint on how to solve this without telling us the solution? And it's always a good way to get some pointers.
Depending on how stuck I am, I also sometimes read other solutions, but I try to find solutions in other languages than the one that I'm using, and preferably even other paradigms. So if I'm doing it in, I don't know, I did Haskell a few years ago, and then I would find someone's C or Python solution that would necessarily be completely different idioms and completely different strategies, but it would give me a way to gain understanding about the problem. And then I would still have to figure out the solution on my own, because I think when I started out, I always thought finding the solution myself and figuring it out was the point of it. But now I'm more in for the learning, and then looking at someone else's solution isn't failing. It's another way of learning, basically.
The point of it is whatever you make of it, I would say. It's
yes.
As long as you're getting something out of it, whether it be fun or learning, then you're doing it right.
The really interesting thing about all three of your answers is they're much more focused on the learning and kind of self-development part of it. And I don't think any one of you has said, I get up early every morning, set myself up, get ready so that I can solve it as quickly as possible and monitor my spot on the leaderboard to be super competitive. What do you love or hate about the competition?
It's funny that you say the competition, because that's kind of almost the worst part for me, because that adds a level of stress. I would be entirely fine without the leaderboard as well. Then I wouldn't have as much pressure, because I do compare myself to other people afterwards and then usually feel bad about it if I'm slow.
Jimmy?
It's fun problems to solve, and usually the theme of the problems is very fun as well. They make no sense. Last year you had these crab submarines and they can only go horizontally, and it was okay, I guess from a problem perspective that makes sense, but in the real world, what does that even mean?
As Tomas said, it's a good way to learn about computer science if you didn't study it. I especially like Advent of Code of 2019, where you have to build this int code computer, which is quite deep in computer science knowledge, and it's really cool.
I loved that year. That was building that thing. I love every part of that.
Yeah, I remember there was a colleague who was trying to do a different language per day, and he just gave up because you have to build your solution on previous days.
That was also a very good year for the sort of Advent of Code community, because one of the things that I like a lot about the Advent of Code version of having a, programmer competition or whatever, is that it gathers so many different people with so many different backgrounds and so many different skill levels in programming. You have anyone from the people that have a chance of getting to the top 100 leaderboard globally. They're super skilled at competitive programming. They solve the problems super fast. The first day can be solved in 15 seconds by some of them. And then you have people like me who just do it for the lulz, but everybody is solving the same problems. They have very similar inputs and they have the same things on their mind for a month. It's a little bit like the Wordle craze, when suddenly the entire world felt like it was playing the same little word game. And because it was the same word every day, it was more connecting than it would have been if it was just a problem. You can go do Project Euler, for example, but that's not the same thing because you have no idea who's solving the same problems as you. With Advent of Code, it's everybody at the same time. So you can talk about the problem with your colleagues, you can chat about it with strangers on the internet, you can trade hints or whatever. So it really builds this connection with everybody. And that I think is really cool.
I think that is a very good point, actually, because I tried after December to continue with the problems on my own, the ones from previous years I hadn't done, but it's hard to get the same drive as during December.
How long does solving these things take you, and how committed do you get to figuring it out? And at what point do you, I don't know, either give up or kind of keep working? Like, what sort of time scale are we talking about here?
The worst one for me was one that ended up in like a lot of modular arithmetic mathematics that I didn't know off the top of my head. And I was like determined to figure it out on my own. So that day I spent like 15 hours solving that problem, just banging my head against that wall. But then the rush of like, when I actually made it, it's like I had this number and it was the right number. I was ecstatic.
Some days the problems are easy enough that I can solve them in like maybe an hour or so and then still not be shamefully late for work. And then other days I have to force myself to close the laptop and then come home and keep working on it in the evening. And towards the end of the month, I usually don't solve the problem within the time I have available in one day. So I will be working on the same problem for several days and just like reading the next one to see if it's something that I can solve easily. But if it's not, I'll just keep it laying around for later until I've finished this one. I usually end up solving like 20 of the 25 days, and then I have to do the rest afterwards if I want all the stars.
I do the thing where I'll do all of them, but then I usually get to some point during the month where they start taking up too much time. And then I'll either skip a problem or come back to it later. And I almost always get to January with like somewhere between 1 and 4 that aren't done. And slowly kind of over the next few months, I'll solve them. Like right now, it's March 10th. And I think I still have one whole problem and I think 2 second halves left from December. And I'm pretty confident that by like Thanksgiving, I'll have them solved. But if that's in the next 2 weeks, or if I end up doing it in August, I really can't tell you right now.
Yeah, the longest one for me, I still remember it was day 18 in 2019. It was a pathfinding problem, and I just went with the wrong algorithm. And I think I tried like different algorithms like DFS, A star, and D star, and it didn't work. I spent 3 days on that problem. I even like tried to run my program overnight. Then it crashed because of out of memory. But eventually I gave up and I went to look for other people's solution and found out I was just using the wrong algorithm. I should have used BFS instead.
That actually ties neatly into the next thing I wanted to ask, of if there are particularly memorable specific questions that stand out to you. I feel like everyone has a story or two of this one day with this one problem.
For me, it's definitely that card shuffling problem with the modular arithmetic that I spent 15 hours on. I invested so much like emotional anguish in that problem. So when I actually solved it, it was like huge for me. But another fun day was like, at some point I was like, oh yeah, I probably should learn like a good parser library for Python, because I don't really know one off the top of my head. So I spent the day like, okay, I'm going to learn this library now. And then the very next day, there was a problem that was literally just like, here, make a parser. And so I was like, oh, I know this now. So I got lucky.
That is kind of awesome. Tell me a little bit more about the card shuffling problem. I don't think I remember that specific problem.
The problem was basically about you have this machine that produced a few million cards, and then you had different types of algorithms or moves you could make. You could cut the deck in half, or you could lay them out and take every other card or something like that. And then you had like a script that you had to follow to shuffle the deck. And so your first step was just like executing these steps on these like millions of cards, and that you could do in memory. So that was just like making a simulator for it. Step 2 of it was, okay, so you leave your card printer running overnight, and when you come back, you have like 50 quintillion cards that you need to shuffle, and your shuffling algorithm script, you need to run that like a bazillion times as well. Because the question was like, okay, which position in the deck does the card that started at position 2019 end up at? So it was like so obvious that you couldn't just execute it because death of the universe and stuff would come first. And there was like a lot of steps to figure out, okay, how do I go from this simulation implementation I have to something that just tracks?
Yeah, those are always the fun ones.
I also remember day 15 from 2018. That's the day I gave up that year. Basically, you were given a number of maps, I think, that has like goblins and elves in, and you have to like calculate it. I don't remember exactly, but I looked at input format and I thought, no, I can't do this in Erlang, so I gave up.
I have good memories from both of those problems as well, but I think day 22 of 2015, which is the first year I solved and also the first problem that I couldn't solve. It was actually sitting unsolved for over 5 years. So the problem is basically a role-playing game situation where it's a boss fight of some sort and you have to figure out which move to make to win the fight. And there's some constraint to, I don't know, spend as little mana as possible or have as much hit points left as possible or something. And back in 2015, I was struggling to come up with a perfect strategy of analyzing the current stats and just choosing the best move. And I couldn't do it. I had no idea. So I dropped it and forgot about it. And then after finishing 2020, I decided to go back and finish all the problems that I hadn't solved before because I was having post-advent of code depression. Yes, that's the thing. And I looked at it and hey, wait, this is just a breadth first search problem that I build the state space of all the different combinations of moves, and then I find the first one that works. Cool. Now I'm done. And I realized then how much I had learned in 5 years of Advent of Code, because that problem that was completely impossible when I attempted it at first, it was basically straightforward when I came back to it a few years later. And I would say that all of the things that I had needed to learn to be able to solve the problem, I had learned from Advent of Code in the meantime.
That's really, really cool. I also think that there's an awesome symmetry here in that you said that the solution was breadth first search, and just a few minutes ago we were talking about a different hard to solve problem where the solution was to stop using fancy algorithms and do a breadth first search. So it's one of these when in doubt, just go back to searching around in the darkness for a number, and maybe that number will be the right answer. What are things you remember learning from Advent of Code, the top of mind things when I ask, what have you learned?
Definitely that kind of search algorithms comes to mind first. I didn't know what A* was or how to actually implement BFS or DFS on a real problem. I had heard of them and I sort of knew what kind of problems they solve, but I couldn't actually use them for anything 5 years ago. And now I feel comfortable with them.
Yeah, I totally agree. Algorithms, definitely. And I feel it also helped me getting to Spotify somehow because I was really terrible at interview questions and also learning new languages. So I've so far tried Erlang, Haskell, Java, and Elixir. And I'm planning to learn some Go, using it in the future too.
Fair warning, Sophie. Golang is hard to do in Advent of Code because of the lack of generics. So maybe next year it's better because Golang 118 is getting generics, but I did it now this winter and I struggled a lot.
Yeah, then I will maybe wait for Go 18 to come out then.
So I want to go back to the point we made before about the time of day that we're getting into this. Do you feel like this really impacts you for kind of all of December? Does your productivity drop? Does some of the rest of your life get impacted either because you're thinking about this a lot or you're up early so you're losing sleep? How much does this really change your work especially, but also just your life in general through the 3.5 weeks of doing it?
I usually feel like my life is working much better in December because I have this rigid routine of I'm getting up at 6 o'clock and that means I have to go to bed at a reasonable time at 10 or something. And I keep to that and I eat nice. For me, I feel a lot more healthy in December thanks to Advent of Code and honestly more productive as well at work because I have this kind of mental head start. I'm warmed up in the morning. Then when I get to work, I just keep doing that.
That's amazing. So we just need to call you at 6 a.m. every day and throw a random software problem at you to get you to eat better. And
that would probably not improve my mental well-being, just that part.
Yeah, it definitely affected me negatively. I've also seriously thought about taking the months off just for AOC. I hope my manager isn't listening to the podcast now.
When you say it's impacted you negatively, you mean work productivity or more than that?
Oh, maybe more than that. Sometimes when I have unfinished problems, I just can't think of anything else. So I would delay cooking food or going to bed, for example, and that's usually not good.
Yeah, that makes sense. And I will make sure that we cut this part from the version that your manager streams.
No, I was joking. I know my manager also does AOC.
Exactly. He participates just as much as the rest of us. And I believe he gets just as obsessive about it. I'm curious if you have any rituals around the way you approach it, since, like you said, you get fairly obsessive about it. Is there a specific thing you have to do before you start to make sure you have the right state of mind or anything like that?
When I get up, I usually put on a kettle of tea and then I take my morning robe and I sit down by the computer and then I start trying to figure out the problem. And if it's like an easy one, then I won't drink my tea. I will go back to bed afterwards. And otherwise, if it's a hard one, then I will, oh shit, it's one of these. I actually have to pour the tea, put on some actual clothes, and then I sit down and like bonk my head against the wall, so to speak.
I do have this thing like looking at the problem in the morning and then not actually attempting to solve it at the computer until maybe an hour or so later, because I can't start coding. It forces me to think about the problem and figure out if there are more different ways that I want to try. I spend more time thinking about the problem than I would if I would just read it and then sit down and try to solve it directly. Sometimes I think it helps me.
Yeah, it makes you at least think through maybe the wrong algorithm before you've coded it and throw it away.
Yeah. And I mean, sometimes you start thinking about the naive solution, and then because you have the time, you also start thinking about, okay, but how can I optimize this? Or is there something I can do that's smarter? And there was one such problem. I don't remember which year it was, but 16 or 17 maybe, where you would simulate some light beam that would go through a bunch of locks that would be open or closed. And you had to figure out when to send the beam for it to go all the way through without being blocked. And I started thinking about, okay, how should I implement the simulation and how complex will it be to run and will it be fast enough and stuff like that. And then in the shower, I realized, hey, wait, this is just modular arithmetic. I don't have this exact solution in my head, but I understand how I should approach this. And it's not building a simulation, it's something else. So when I sat down to code, I could go with the right approach from the start, even though it wasn't the first approach that I thought of.
So many times you've started a problem and then it's like, you start doing it as like, no, but this obviously won't work. And then it's like, oh, if I just think of it like this instead, that's like, oh, that's obviously the right way to go. So I think it's doing that the way Tomas is doing is probably the best way to get a good solution at your first attempt.
Yeah, or at least at the first time you code it.
Yeah.
Normally just like start by using brute force, and then slowly I would add optimization to it. If it doesn't work, I would try to seek out other solutions. It turns out brute force plus memorization is usually good enough for most of the problems.
Thank you all so much for joining us. I love digging into this topic with different people and hearing how they approach it and what they think of it.
Thank you.
Thank you.
Thank you.
For most of the participants, the real competition is against yourself, challenging yourself to learn a new language, seeing if you can complete all the puzzles that year, and just finding out if you're getting any faster at solving them. And that's a good thing, because if you were really trying to win each year, you wouldn't have a chance. Year in and year out, there's one name at the top of the Spotify leaderboard. Last year, he was number 35 on the global leaderboard, number 35 of 220,000 participants globally. I've been participating for the past few years, and there hasn't been a single day when I finished in the top 100, much less a whole month. His name is Jimmy Mordell. He's a staff engineer on the platform team at Spotify. And every December, he kicks our collective butts.
Hi, I'm Jimmy Mordell.
Jimmy.
I'm a staff engineer at Spotify. I've been at Spotify for a bit more than 11 years now. The last couple of years, I've been working, trying to understand developer productivity, if you will. So more on like the organizational side and helping my department, the platform mission, and to be more data informed in its decisions.
Let's jump into the theme of this episode, Advent of Code. You're a bit of a legend at Spotify in how well you do at solving these problems.
There are many reasons why people do Advent of Code puzzles. It's a good excuse to learn a new programming language. And some people are just happy to actually just write code instead of, doing whatever they do at work. And then there's also this competitive element, which is really at solving the puzzles as fast as possible. So for myself, I have a background as a competitive programmer, primarily from my university days. And those are some skills I still carry with me, and I've been doing pretty successfully on these Advent of Code challenges. So there's a global rank list. I think I was number 30 or 40, something like that this year. And at Spotify, of course, I'm usually the fastest to solve each puzzle every day. Not all days, but most of the days.
So tell me a little bit about that competitive programming background.
I've always been programming since I was 7 years or something, and I always liked puzzles, and I also have a sort of, I guess, a competitive element, not just in programming, but in sports and other things as well. And turned out I've been pretty good at it. Competitive programming is essentially solving programming problems that are in an algorithmic nature. So you're giving a very concrete problem statement, a bit similar to what you might end up with on job interviews or maybe what you did in university school, but usually much harder. And you're given a couple of these problems and you're supposed to solve them within often a couple of hours, as many as you can. And yeah, you need to figure out the correct algorithm, implement a solution that produces the right output for a given input. That's kind of the simple way of putting it. And I started doing it in high school. There's an international competition called IOI, International Olympiad in Informatics, and that's still going on. It's the most prestigious event for high school students. I was practicing for that a lot, and I competed in 1997 in Cape Town. It was the final, so there were 4 people from each country. So I qualified for that for Sweden, and I did pretty well. I came 10th place in the international competition. And at university, the most prestigious event there is called the ICPC, or ACM ICPC, which is actually a team competition. You have 3 people sharing one computer, which kind of gives you a hint of how old it is, because it came from a day when computers were a scarcity. We advanced to the final was in Vancouver in 2001, I believe. And I think we came 11th place. And curiosity, one of my team members is actually also working at Spotify these days.
That's really amazing.
And then there's also a lot of commercial actors using this type of style of problems as a way of recruitment or just being in the R&D community. So for instance, there used to be a company, they're still around actually, called Topcoder. There were actually competitions on a weekly basis with prize money, smaller prize money, and then they had 2 competitions every year with significant prize money. So that was, of course, as a student, that was very nice. I was actually spending probably more time in my university years like practicing on these type of problems in competitions than studying. I actually never finished my graduation, maybe because of this, I don't know. But it's kind of went well for me anyway, I think. Yeah, and I think my best achievement when it comes to this is in 2003 when Google organized their first Google Code Jam, which I won. I think it was 5,000 people originally, so that was really nice. In fact, the reason I got a job at Spotify. So Spotify actually hosted a programming competition in 2010 that I won. After winning that, I had a lunch with our then CTO, who was trying to convince me to work at Spotify. But then I started working, and since then it's been pretty much going downhill. So I haven't really done much competitive programming until Advent of Code, I guess, turned up again.
So yeah, so at least your path to Spotify was also winning a coding competition. Yes,
exactly. Regarding Advent of Code, I think I looked at the problems and I thought, this is just way too easy. This is not a challenge even. It's just, this is so easy, so I didn't bother. And then I noted that there was a community being built up in Spotify around this. In particular, my nemesis, or our chief system architect, was doing really well in these competitions at Spotify.
You mean Jan?
Yes. And I felt like, I need to beat him. My competitive spirit started. So I felt like, okay, I need to try this out and see if I can still be as fast as I was once upon a time.
I think it's funny to hear you talk of kind of anyone at Spotify as a nemesis when I think once or twice a year someone will beat you, and that's about it. So whether it's Niklas or not, it varies. But I think it's very funny to hear you think of anyone at Spotify as genuinely competition.
Yeah, I think he called me his nemesis or something like that. That might have been it. But it's really friendly, and I mean, the most fun thing is just talking about it later and sharing the experience. You get to talk about it afterwards and like see how did others do it, how did others approach this problem, and were there some shortcuts you could take or some ingenious trick in my programming language that didn't work in another.
Yeah, I think a lot of us have talked about that as being a super valuable thing of the Spotify community around Advent of Code. I'm curious if you have memories of like exciting learnings and things that you really got from doing Advent of Code with this community.
Oh, since I'm usually the first to solve most of the problems, I haven't learned so much.
Jimmy.
One thing you do learn pretty quickly is that you should be a bit more pragmatic because of the way these particular problems are created. So typically in these programming competitions, you write a program, it reads input files, and you produce an output file. And usually they can very often be various corner cases that you need to consider and like first figure out what the corner cases are and then how to handle them. In Advent of Code, since there's only one input for each problem, usually you don't have to worry so much about corner cases, because usually there are no corner cases, which means you can cut corners in your solution. So that's, I guess, one thing I learned is that don't overthink the problem.
I guess maybe not learnings then, but are there any particular problems that are very kind of fresh in your mind as ones that either you thought were really good or ones you did a really awesome job, or maybe on the opposite, like you really struggled with?
I mean, I know this is a commonly held opinion at Spotify among the people that tried that on the code, is that in the year 2019, I think, we had this series of puzzles called the int code challenges. So where you essentially, over a couple of days, you built up a virtual machine, and then you solved problems within that virtual machine. That sort of made everyone have to understand the same programming language. So you had to first implement a simulation, like an emulator pretty much, for this very specific machine's assembly language. And then the input was usually given, okay, so here's a program written in this assembly language. Now you should do something with it. So for instance, I do remember one problem was, okay, here's an assembly language. Okay, when you run it in the machine you built over the previous day's problems, you realize, okay, this is a clone of Breakout, the classical arcade game. So it's actually playing Breakout, and now you need to write a program that sort of modifies this existing program so it plays Breakout for you, so it cleans the whole board. It's a very ingenious problem, and they had multiple problems in that way, that first required you to write a machine and then maybe doing some parallel computation or hooking machines up with each other to produce some results. There was one problem that actually had a pretty nasty corner case, which essentially it was similar to Game of Life. So you had a sort of a game of life simulation. Instead of having a fixed set of rules, you had a sort of a dynamic set of rules. And the trick here was that made this problem stand out was that you had an infinite grid. So usually you're working with a finite grid, but here you had an infinite grid. And you had this operation that happened simultaneously on the infinite grid, and it affected all cells on the grid, like an infinite amount of cells. So what you'd actually do, okay, let's pretend this is a finite grid with a fixed scope. But that actually doesn't really work because you didn't realize that the grid was infinite, and it flipped the pixels in the Game of Life situation in a way that it was very curious, because it's like, so they had an example input where you got away with a naive solution, and then on the real input that you were supposed to answer, you got the wrong answer if you had implemented it in the most naive way. And it took me, I don't know, 20-30 minutes before figuring this out, and it's a lot of people stumble on it. That was a nice problem in the sense that they actually tricked you a bit. You took a shortcut, and the shortcut didn't work.
No, I remember that problem. That was this year, and it was a tile floor where I think you were supposed to use the colors. They were all black and white, and the colors of the tiles adjacent to the one you're on to create a binary representation. And then that binary representation would tell you which bit in like an input mask to look at to figure out the new color of the tile. And I think to your point about the infinite one, the ones on the edges would be either 0 or whatever it was, 255, let's say, whatever the max number was in their binary notation. Mm-hmm. And in the input data, they always kept the outside of the tile floor blank. And then on the final input data, the outside one oscillated between white and black.
Yes.
And that meant that you have an infinite outside that switches and thus flips all of the binary values around the edge of your kind of finite grid that you're playing with from zeros to ones and back. And I remember a lot of us struggling with that. You solve some of these things in minutes, like less than 4 minutes sometimes, like an amount of time it could take you to read and understand the problem. So what is the Jimmy process for getting from I just refreshed this page to I've submitted an answer in under 4 minutes?
Yeah, and it actually starts before 6 a.m. because I think I set my alarm at 5 minutes for 6 a.m. or something like that. But I mean, you need to prepare so you can download the input with just a single command or something like that, so you don't have to copy paste stuff from the page. And I mean, the adrenaline is pumping. I mean, that's definitely for sure. I mean, it's a competition after all. But the only thing I need is that all the windows on the computer are on the right place. So I have my web browser in the upper left corner. I have my coding window in the upper right corner. I have my terminal in the lower left corner. And then I hit refresh at exactly the second when it happens, and then scrolling down, reading, and then switching over. I mean, that's the rhythm.
That's why I'm not winning. I put my terminal in the wrong corner.
I'm not a superstitious person at all. I like routines, but I'm not superstitious. But then, so when a problem opens, I mean, as I said, I actually looked at the first problem or the first subtask, the first problem, I submitted after 44 seconds this year. So 44 seconds, from that you actually have to read the problem statement, understand it, download the input, write a program, write it correctly, run the code, and copy and submit the answer. So all that in 44 seconds. And the problem statement was 2 full pages of text. So what I did, and what I always do, in particular on the first set of problems, but that I look at the last sentence, because the last sentence is usually, how many can you do this? So now I know what's being asked for. And then I look at the sample input, which in this case was a list of integers. So this time here it was, how many measurements are larger than the previous measurement? So that was the first thing I read. Then you see a list of integers. Already by that, you can almost guess what the problem is. Like, how many integers are larger than the previous one? I mean, maybe I read a bit more, but there are a couple of more words highlighted in the text, which are important words. So I look at last sentence, sample input, the highlighted words, and then I sort of guess what the problem is. I only do that for day 1 and day 2, because I know usually there are no tricks or anything. You just do as easy as you can. And then, I mean, usually the solution is you already have some kind of template loaded. So it's really just typing 3 lines of code or something like that. And you run it. There is absolutely no point in testing on the sample input on this, by the way, because you might as well run it on the input that you're given right away and just submit and hope for the best. Because if you were to test on the sample input, because then you know, look, on this input, it should produce that output. Okay, so if I do that and see that it's correct, I've just lost time. I lost the 10 or 15 seconds to run it. And if it's wrong, I can't submit for 1 minute. That's the penalty. I have to wait a minute. But it still will probably take me a minute to actually find the bug. So there is no gain. I only lose time. So that's my strategy on the easiest problems.
Yep. So first I have to say that's amazing. Just approaching it that way. And then even the couple of things you said, like, oh, we have this template loaded and it's just a few lines of code. I don't think I know many people that would have thought to approach it that way, even if someone said, I don't know, in 2 hours, I'm going to throw a simple coding question at you and I need you to solve it as quickly as possible. Do whatever you need for the next 2 hours to prep, and then I'll throw it at you. I certainly wouldn't have ended up at what you just said, but I think most people wouldn't. So I find just the way you described the way you do days 1 and 2 really interesting. But I want you to keep going. What do you do when it gets harder than just read the last question, code something that makes sense to you, and you're almost always right?
Yeah, so when it comes to the template, so that's also something you learn what is useful, because you kind of see a pattern. So the input is usually in different formats. I mean, the challenge shouldn't be about parsing the input. So the input is given to you most of the time, at least in some sane way. So usually it's reading integers or reading words or tokens. So you should know beforehand how to do that. And I'm using Python, which is it's not what I used to do back in my days. I've used a lot of different programming languages for competitions. I don't think the programming language is really the key. Some people might think that C++ is best. C++ is still, I think, the most widely used one at the most prestigious competitions. But I use C++, I've used Java, I've used C#, and now I'm using Python. So I used all languages. And to me, what you're most code fluent in, which happens to be whatever I'm using mostly at work, is what I'm using. Something I started doing is after each day's puzzle, I was like, is there something in this that I shouldn't have had to type here, but that I could move into a library because I know it might want to be reused later? It's actually kind of fun, because then it gives you some time to can you structure the code and do something more than just ugly hacking. So for instance, in this most recent year, I've started building a small library for dealing with grid problems. Kind of a, not common, but it usually appears a couple of times per year, is a problem that somehow involves a grid. But there's always kind of small things that you would want to factor out and make a sort of like library, so you don't have to type all this boilerplate code all the time. The valuable, precious competition time you should spend on unique stuff that you don't have to type again. So you really need to have this huge coding library. It kind of grows over time, and it's something, as a competitive programmer, you do build up a huge coding library time. And you can download a lot of coding libraries, but I think it is a great value in actually building them yourself. One trick I often do, and this might be good advice, is that when the input becomes a bit more complex, for instance, a maze, figure out a good data structure to represent the input. And then step 1 of the code is just read the input, put it in your own data structure, and then I always print out, like debug printing my data structure to see that have I parsed the input correctly? Is it stored the way I expect it? I don't want to write actual business logic for solving problems before I verified that, because then I can kind of forget about that step and move on with the actual problem. So for instance, on day 23 this year, we had this problem of, it was essentially kind of a Sokoban, I think is a classical game where you're moving boxes around in a maze. So you have a couple of boxes in some positions and you need to move them out of the way and into some other places. So the problem was called Amphipod, and that's actually a good example of how should you represent the input. It's obvious it's a search problem. You have 8 boxes that are in 8 different locations in a maze, and they should be moved to 8 other positions without running into each other, so they are obstructing each other. So you need to figure out a good way of representing this. So you're giving the input as a grid, but it's probably not the best way to represent it when doing the search because it's a bit too much overhead. So that was actually the hardest part, and I actually got that wrong. This was not my best day. That was partly because I selected the wrong data structure. I should have stopped and thought a bit more about what I'm doing instead of, sometimes I have a tendency to just go with the first thing that pops in my mind, which is good for most of the days, but not when it actually is a hard problem. For me, that's one of the challenges, is like, should I just go with the first thing that pops in my mind? Or should I stop and think of 1 more minute, possibly losing a minute? Or it could save me 5 minutes. Like, coming from the competitive angle, these are like really hard decisions that you need to make. I think that what makes this really something I call a sport, because it's like decisions that any athlete have to take all the time if you're playing soccer or whatnot, like what decisions to make.
That exact same thing is also what I do if I'm struggling or if I'm not sure what to do, or even just to get moving. The first thing I do is I decide on a data structure and I load the data into it, and then I create a way to debug print it and make sure that it printed the right thing. And oftentimes doing that will teach me that it was the wrong data structure. And the funny thing is, with the way you described the way you approach the problems and how you don't really test it and how you just look at the last sentence, I figured that the one thing you were going to tell me you don't do is debug print your input, that you just kind of go through, get a number, and submit that number. And only if that number is wrong do you then even consider adding crazy time-wasting things like debug printing. So I was surprised to hear you mention that early on.
Yeah, but it's only for the harder problems that I will do that. And for Advent of Code, when I say harder problems, again, compared to what I've done in the past with IOI and ICPC and Google Code Jam, almost all problems here are easier than even the easier problem. So in that respect, like from a purely algorithmic point of view, like figuring out which algorithm, which efficient algorithm to use. In Advent of Code, it's very seldom that you have to come up with a really efficient algorithm.
One thing that I found surprising about Advent of Code when I started was that the entire kind of leaderboard part was time-based. And I hadn't done many competitions, but I remember the few times I did them, there were a bunch of other aspects like time complexity or cyclomatic complexity of your code. There would always be a few metrics of the solution you submit, and they would weigh into some combined score. So when I first started doing Advent of Code, the first couple of problems, I kept trying to like write the simplest, fastest, most efficient thing. And that, of course, took me much longer than writing whatever my computer could solve in a few seconds. So I'm curious if some of these other ones, the more prestigious competitions with the much harder things you talk about, if it's always time or if all these other factors weigh in as well.
It's very binary. Either the problem passes the input within time or it does not. But usually, to your point with complexity, is that if they pose a problem, there is sort of an expectation that you need this problem to be linear in time complexity or quadratic or n log n or whatnot. And if it's not, it will not work, because the input will be constructed in such a way that if you don't have the most efficient possible algorithm that there is on a theoretical perspective, it won't work. So that way, there is no need for having a judge to look at the code and inspect it manually to say if it's good enough for that, because you have the automatic system testing it. So usually there's always one right answer.
I think the reason with Advent of Code that this comes up to me is that sometimes there are solutions that just kind of make my CPU fan go crazy for 4 minutes, and that's fine. But someone else will have a solution that they solved in like milliseconds, and either one kind of gets me reasonably high on the leaderboard.
Yeah.
But it feels kind of dirty to submit the one that like blew up my CPU for 4 minutes.
Yeah. That's really where I like the discussions afterwards. Like you see people, I wrote this ugly solution, it took 1 hour, but I finally got it. And then you discuss and you realize someone else did it in like a solution that just took second or milliseconds to run, and then, like that's I think where the most fun is. I do admit I've also had some ugly hack solutions like that on Advent of Code. Not often, but it has happened. Sometimes you just need to use various heuristics, so it's kind of hard to know beforehand how long this will actually take to run, and it kind of depends on the input as well, so it's hard to make a call. I'm running the solution, my fan goes crazy. Yes. Should I press Control C and try to change it? Or maybe it would have finished if I let it 5 more seconds. So you really need to add some kind of progress bar here if that's even feasible. Maybe sometimes it's not feasible. Yeah, that's a tough challenge. Luckily, you can code for your next iteration while the old solution is still running in the background, usually.
Yes, I am extremely familiar with that agonizing decision of whether you cut it off or not.
Yeah.
Thank you so much for joining us. I think this was super interesting, especially for those of us that don't come anywhere close to doing as well as you do and just watch in awe as you beat us every day by many minutes.
It's always fun also to see some people learn. And sometimes, I mean, I'm always I never get grumpy if someone actually beat me one day. I think that's just good, to be honest, because otherwise I might get bored.
What are other things that you nerd out about?
I don't think I have that many nerdy hobbies. I have kids, so that tends to be where I spend most of my time. But I have nerdy kids, so like we do a lot of nerdy things together, including building Legos or playing games. I'm trying to get them into programming with mixed success. The one thing that actually finally stuck with my younger kid, he's been playing Roblox quite a bit and then got into that sort of Roblox community with other kids and other teenagers to build their own games within Roblox. And that was honestly how I got started as well. Like I wanted to build my own games when I was young, and that was how I got started with programming and figured it out completely on my own as well.
My bookshelves behind me are just chock full of board games. That's basically why I got into programming in the first place, because of the puzzles and the problem solving. I like these very strategic, thinky type board games where I have to figure out optimal strategies and solutions to things. I'm a big fan of Scythe. Classics like Dominion and Carcassonne are always fun, you know. Spirit Island is an absolutely fantastic cooperative game.
I'm not sure what counts as nerd hobby, but I like anime. I have like 2 years in a row got Otacore as my top genre at Spotify, so I guess I'm a Spotify certified weeb now.
I'm gonna say this counts as nerding out, but I spent quite a lot of time singing in choir. So I practice choir once a week and we do concerts every now and then. And obviously not only, but I also listen a lot to choir music. So if you look at my Spotify history, it's like half hard rock and half choir music. And all the recommendation algorithms are very confused.
So right now I'm actually working on a computer game on my old 8-bit computer that I grew up with. So it's mostly written in Z8 assembly language, but I found this pretty awesome development kit on the net, so I can combine assembly with some high-level C code and also a lot of pre-post processing on a PC. And I actually found just the other day that there's actually a yearly competition for that platform. So I probably will submit my game whenever it's finished, if it ever gets finished, to that competition.
Thanks for listening to Nerd Out at Spotify. We hope you enjoyed this peek into a little corner of Spotify's engineering community, and we hope to see you on the leaderboards this December at adventofcode.com. Good luck. You're gonna need it. Nerd Out at Spotify is produced by Spotify's Ted Vergakis and Seaplane Armada, who also wrote our fantastic theme song. I'm Dave Zolotusky. Thanks for nerding out with us.
Jimmy, 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 Jimmy.